Look, guys. And Bourgeois is officially haunted. That's cool. All right. Part two. This is weird. The same muscles that are pulling my trunk this way are also trying to pull my pelvis this way. It's weird. The same muscles that are trying to pull my trunk this way are trying to pull my pelvis this way. It's weird. It's why we practice. Okay? The same muscles that are trying to pull. Let me see if I could visualize this. The same muscles. So here's the trunk and here's the pelvis. Trunk, shoulders, hips, pelvis. The same muscles that are pulling this way are trying to pull this way. That make sense? So I know he has to be using left transverse trunk rotators because gravity's trying to twist his trunk to the right, and I don't need right transverse trunks. That's how I do it. You might make it easy and say, listen, hold forces and hypothetical, give me a motion. Give me something that I know I have more confidence in. We could do that too. So from A to B, it's not even called forces. Let's talk motion. From A to B, I'm going to have right transverse pelvic girdle rotation. So therefore, I'm going to have left transverse trunk rotation. Make sense? So you put that as your given. External force, agonist, motion, contraction. Put your motion. Yeah, I broke the ice. You had left transverse trunk. Does everybody see that? Was gravity trying to cause left transverse trunk? No, gravity was trying to cause right transverse trunk. So I must need left transverse trunk rotators. There's my agonist part. Now you have two of the three variables. Left transverse trunk rotators do left transverse trunk rotation through concentric contraction. Guys, some of these are going to be easy. And some of them will be hard. But just because they're hard doesn't mean we shouldn't do them. Because as future therapists, personal trainers, fitness coaches, doctors, we need to be beyond core. I totally get why people just say core, because this is not easy. But it can get easier. That's the key. It may not be easy right now, but the more we practice, it can get easier. We just have to have a process. Okay. Any questions about A to B before I give you a little bit more time to do the B to C, C to B, B to A? Okay. Why don't you take another minute to reassess your answers? Maybe that kind of helped kickstart you. And then we'll finish going over it before classes are done. It's all good. I've heard words. Heard a lot of words. Been teaching for 20 years. One time, someone's phone went off. And I was like, who is it? And they were like, it's my mom. It was her mom. Or, yeah, it was a long time. Like, let me talk. That's let me talk. Like, yeah, this is her first time coming to class. And then, like, I turned on, like, my thick Delcom accent because I wanted to think, like, oh my God, what she learned. That's all this was. Yeah, all right, we got to go back to class. We learned about the pinky. Grace, were you here in biomechanics when we did the finger thing? That's fun. Also, I mean, we've said it before, but I want to remind you, your chair, it's set up perfectly to try to figure this out. Like, and you don't even have to get up. So obviously, it's not going to have the same exercises in your chair, but in terms of reminding you of the trunk motion, your swivel chairs are great. Swivel it. All right, guys, let's do this. So we already did AB. I think this is a perfect illustration of why we don't assume. We don't assume because going from A to C is one motion, same motion, but we can't assume it's going to be because of the same muscles. Does that make sense? It's the same motion. Right transverse pelvic the whole way, left transverse trunk the whole way. But we can't assume it's going to be the same muscles because when the feet are on the left side, gravity's trying to do this. When the feet are on the right side, gravity's trying to do that. Gravity's trying to do two different things. Does that make sense? When the feet are at A, gravity is trying to left transverse pelvic girdle rotate. When the feet are on the right side, gravity is trying to right transverse. Okay? So from B, midway, to C, we're going to play the same game we did here. Gravity is trying to spin my pelvis to the right, thus trying to spin my trunk to the left. I don't need muscles that are trying to spin my trunk to the left. I need muscles that are trying to spin my trunk to the right. Does that make sense? Now, the motion is left transverse trunk rotation. Right transverse pelvic, left transverse trunk. So how can I have right transverse trunk pullers do left transverse trunk motion? Eccentrics. Guys, if someone came to my office, a student or colleague, and said, Campbell, I need some help understanding the muscles from here to there. We're doing an experiment. We want to make sure we have the muscles right. I will not have an answer for them right away. I'm like, okay, let's figure it out. Figure it out. So that should be comforting. Like, this is not easy stuff, but at least we have a process to be able to figure it out. Cool. So, and listen, you may be able to see contraction. Like you may be able to know, oh, that has to be concentric. It's going with gravity. Oh, that has to be eccentric. I'm sorry, it's going against gravity from A to B. That has to be eccentric, going with gravity from B to C. Cool. Put it down as a given. If that's your jam, then reverse engineer it. I just want right answers. Okay, so we did B to C. Now let's go C to B. Gravity is still trying to twist you to the left. I don't need those muscles. I need right transverse. The motion matches the muscles pull. Same muscles on this side, but the contraction changes. Makes sense. If you have different motions in the same muscles, your only option is to have different contractions. And then from B to A, that would be eccentrics. Gravity is trying to twist my trunk to the right. I don't need those muscles. I need left transverse trunk rotations. Are we feeling better? Look, if you can do this quick, bless you. That's awesome. I just want right answers. And so don't assume, but we do the same process as we do with curls. Right? What was the motion? Extension. What was gravity trying to do? Extend me. I don't need extension pullers. I need flexion pullers. Flexors are going to allow extension eccentrically. We're doing the same thing here. It's just the trunk motion is hard to see. That's all the difference. Go ahead, Grace.
Like if you're stuck on this, like identifying what the external force is trying to do, like it's use the random verbs. So like Okay, what is gravity, like?
Which hip? Yeah.
Sturgeon.
Great points.
Just trying to make me look at rubbery.
Mhm.
So my trunk must be influenced by right transverse rotation. So you need your left transverse. So yeah, like landmarks community.
Landmarks. Questions? Okay, how about we do this? How about the plan for Friday is, and I'll try to email the class. I would love, maybe there's bias. I don't mean bias, but like maybe in my mind, I've been doing this for so long, I kind of have the same old examples that I kind of go to. So what I would love is, you guys over the next today and tomorrow, email me some examples, email me some pictures, take some pictures in the weight room or take some pictures of some exercises that you'd like to. So in other words, Friday will literally be us practicing with things you want to practice. You send them to me and we'll do them on Friday. Cool? All right, guys. Y'all have a good day.